Hey YouTube, it's Rich with Kestava. I've been practicing structural engineering for 6.5 years now, if you can believe it. There were things that I did right from the very beginning, but there were substantially more things that I did incorrectly that took me months and sometimes years to correct and figure out. So this is the video that I wish I had when I was starting off learning structural engineering, and how I would learn structural engineering if I had to start all over again. I'm gonna be going through my step-by-step approach on how I would relearn structural engineering. I'll be talking about the correct mindset or mentality as you walk through learning structural engineering, which is something I got really wrong in school and early in my career, and is something that once learned incorrectly, took me years to finally unravel and correct. And then I'll be recommending some resources for your development as an engineer. The very first thing I'd do if I were to start over is become a problem solver. This is the best piece of information I can give to aspiring engineers. And it may sound simple, but I cannot stress the importance of this point enough. It's a bit of both learning technique as well as mindset shift that we'll be getting into. In the real world, there aren't any professors spoon-feeding you information, giving you homework, providing lectures full of useful information, or end-of-semester exams for you to prove yourself. In the real world, there's simply problems, and most of the time, they're poorly defined problems. These problems require solutions that are either acceptable or not. There is no partial credit for solutions that don't work, or sort of work. Think about it. If you design 10 roof systems and one of those systems fails and collapses, you're not gonna get a 90% and a pat on the back. Or are you? No, you're not. You're getting fired. Really, in order to excel in engineering, both academically and professionally, you need to learn not to depend on someone else to provide you everything in order to solve a problem. And that boils down to two things. You need to learn how to discover what you need to know, and then where to go to find it. So what would I learn first? I would cover things like building codes, building design criteria, basic construction types. We're talking steel construction, wood, concrete, masonry, and how those types of structures are put together. Gravity and lateral systems. Now, I know that one is a very, very broad one, but I mean understanding and learning about different types of gravity systems, different types of lateral systems. And I'm not trying to learn how to design every single type of gravity and lateral system. I am studying how these different systems actually work. That's the big component about that bullet point. Moment and shear, drift and deflection, stress and strain. That one's a big one. I can't stress that enough. All right, connection design and construction administration, AKA what an engineer does when the building is actually being built. Drift and deflection. Again, while I would start small and look at beams and elements and components, I would also spend a lot of my time looking at drift and deflection criteria for entire structures, for code examples, and the tolerances that we are permitted for the structures that we build, and where those come into play. That should be enough to get you started. Okay, but seriously, you really need to understand the listed fundamental concepts by trying them out yourself. And don't worry too much about details for now. Another piece of advice is to play around with things a little and explore outside of the things that you're being told to design for. For example, say you're studying snow load criteria and your problem specifies a flat roof. Solve the problem first and understand it wholly, but then introduce new scenarios by changing one thing, like changing the flat roof to a sloped roof. Continue to change the problem slightly, and you'll solidify your understanding of the concept faster, and ultimately, you'll become a sharper engineer. The next thing I wish I did more of was to seek help. Throughout school and early in my career, I unfortunately never truly sought help from anybody. That's not to say that I didn't work with others or ask questions, but see if this sounds familiar. In school, I worked closely with a group of engineering friends in order to get work done. And throughout my studies, I asked questions within my group, particularly about homework, and more specifically about homework solutions. I didn't care too much about the problem or the concept or what it was trying to teach me. I was more engaged with understanding and figuring out the problem to or the answer to the problem itself in order to finish that homework, in order to move on to the next homework, rinse, repeat, and over and over. But here's the problem that I think you're picking up on. I sought answers to individual problems when I should have been seeking understanding of the problem at hand. Problems introduced to you in school are usually designed to introduce you to important concepts that you will regularly encounter and use in your professional career. At least that's how it should work. Seek to understand the concept of the problem before you seek the answer. It's an easy cop-out to simply seek solutions, and I myself did it often. While it can be enticing in school as you have homework after homework after homework after test coming up, I get it. But ultimately, it underprepares you for the professional world and underprepares you as an engineer. But why? The reason? You fail to understand why there even needs to be a solution in the first place. And your thought process becomes unimaginative and stale. I was more worried about the answer being 5 or 7 or 7.6 rather than understanding why, say, lateral torsional buckling is important to check when designing a steel member. Without understanding the why behind a problem, your thinking becomes very linear and you lose the ability to understand when solutions can be optimized or expanded upon. The best engineers I know present clear, simple, and effective solutions to problems. And they achieve this through complete understanding of the problem at hand. And seeking help doesn't just apply to your school years. Seek help in your professional life also. In your early professional career, if there's a concept that you are not understanding, seek out an experienced coworker and ask a clarifying question. It's far better to ask a clarifying question so that your coworker can provide specific information to help you gain clarity and to understand the task at hand. Your coworkers, especially the older ones, have years and years of experience and they're always there ready to provide it to you. Unless, they're assholes. But we'll get through that one together. Let me know down below, do you have trouble getting information from those experienced coworkers at work? Now, don't underestimate this next point. In order to ask clarifying questions, you need to come prepared to your coworker. This means that you need to have attempted the problem at hand multiple times with maximum effort. You can't just cop out and say, I don't know, because you're scared and you don't understand and things are confusing. It happens a lot in our profession, so don't sweat it. But I think it's ultimately about shifting the mindset and realizing as you discover things that you don't know, that you get excited about understanding them and then applying them to your future designs. And that means staying curious, trying problems, trying to get answers to solutions, trying to get answers to the answers to the solutions. You know what I mean? It becomes a point if you realize that you are scared to even try things where you need to rewind and rethink and shift your mindset. And that's the part, looking back, that took me years to understand. So that's the biggest takeaway from myself to my earlier self if I were to restart. And finally, here are some of the resources that I would recommend my younger self if I were to restart and relearn structural engineering. The IBC, the ASCE 7, the AISC Steel Manual, the TMS, and the NDS. Now there's many more that go along off of this, but this is the starting point that I would take for myself. And you're seeing a pattern here. Make the building codes and model codes a major part of your study routine. Use them. I can't stress it enough. And in addition to building and material codes, make sure that you read the texts with purpose. That is a huge one that I can't underestimate enough, and it's sad that I didn't do that when I was studying in school. There's so many reasons why we read textbooks. In my case, most of the time, it was to find an answer to a homework problem I was trying to solve. In an effort to find specific information, I skimmed through most of my textbooks, really ignoring much of what was presented in order to find that bit of information that would help me solve my homework problem. I would never do this again starting over. All engineering textbooks cover important theoretical material, as well as most of the time providing real-world example problems, applying the theory to the real world. It seems like the perfect place to start your studies. And it's something I avoided when I was young. When a text is only used to solve assigned homework problems, you miss out on loads and loads of information that can help you solidify your understanding of the concept at hand, and ultimately it can delay your understanding of engineering and how to practice it many years into the future. Unfortunately, I was more focused on tests, numbers, and getting the right answer. If you liked what you saw here today, hopefully I provided a little bit of context as to how I would redo some things, leave a like down below or leave a comment on maybe some other tactics that you would reintroduce yourself. Let the community know. We're always growing together. And until next time, this is Rich with Team Kestava, and I will see everybody next time. Later.